Hello, so this is the first video tutorial for Lab 3. So this part 1, we'll look at uploading SRTM data from your drive into ArcMap and ArcPro, and how we'll prepare that data to do watershed analysis within these programs. And so in this lab, in my demonstration here, we'll do a little bit of a comparison between ArcMap and ArcPro. So I'll share my video screen here, my computer screen. Okay, so here on the left you can see an untitled ArcMap project, and on the right a basic ArcPro project. ArcPro is nice in that it has like baseline data available of a map for where you're at to begin with, whereas ArcMap is always a blank slate to start. And when you add data into ArcMap over here on the left, we usually use this plus sign. And in our lab this week, we'll be navigating to Geomorphology Labs, Lab 3, and go to this SRTM folder. And within that folder, there's two data sets. Because basically we got this data from the Utah Geographical Reference Center, and they provide the data in tiles for the state, and we needed 2 tiles to cover the entire Spanish Fork River watershed, which comes out of Spanish Fork Canyon along Highway 6 and drains into Utah Lake. So we'll want to add both of those data. So add 1. And to go back in because they're in separate folders. If they're in the same folder, we could add them at the same time. And so the data set are in 1, 2 tiles here. And right away, we can see actually that the properties of the data say that it's in what type of coordinate system. It's actually in a projected coordinate system, NAD 83 UTM zone 12 north. So even though this says it is north 41, west 112, which looks like geographic coordinates, they projected it into Unified Transverse Mercator coordinate system, UTM, which is projected into meters. So actually we won't have to process it into that. Okay, so let's do the same thing in ArcPro. So we'll add data and we'll navigate to that folder, Lab 3, SRTM, add, and add the other one. And so we can see where that lies in the state of Utah nicely in ArcPro. Okay, so the common thing between these two programs, what we have to do next, because what we're going to do is basically zoom in here. This is Utah Valley, this dark area here. You can like kind of have a color ramp if you want to see more details in the digital elevation model. And so I'll just do that for a minute. It's not absolutely critical. But we need to merge these 2 tiles together because you can see there's a seam, and the seam cuts right through the watershed. And the goal of what we're going to do is to build a digital elevation model that just captures where the edges of the watershed's drainage boundaries are. Okay, so what we need to do in ArcMap, we'll do it over here on the left first, is to open up ArcToolbox, and we're going to merge 2 raster data sets. And so that over there, and create a new one. And so the tool that we'll use is under Data Management Tools in the toolbox. So that's the 6th toolbox down. And then within that, you'll find a tool called raster. So open that up. And what we want is raster data set. And we're going to mosaic, not merge, mosaic to new raster. So we're going to move these, we're going to input these two data sets and make a new one. So this is the dialog box that pops up. And so we would add both of those data sets in there. You would then call your, go to your Geomorphology Labs folder, go to students, I mean, go to Landon's, go to yourself, and we'll give it a location. So actually we have to click on the folder, not write a name. So we've input the two data sets. We've given it a folder. My computer is taking some time to think. Then we have to give it a new raster name. And so we'll call this Central Utah DM.tiff. There's a lot of different file formats you can use for rasters. TIFF is a great default, in my opinion. Spatial reference for raster, because these already had references coming in, we don't have to add anything there. The pixel type is important. You need to choose the right pixel type. You need to know what these things mean. 1 bit, the values can either be 0 or 1. This is like computer jargon in terms of what bits mean. Because we have a raster data set, and if we look over here, we can see the values range from, they have digits beyond the decimal, and then they have decimal places. And so we don't just want these signed, but we want to get all the way into 32-bit float data. Float means it has decimals. Okay, so 32-bit float is a good choice. The cell size we don't have to pick, but it does say it's 30-meter data, and I just want to ensure that for my own sanity, so I'm going to put 30 in terms of meters there. It always asks when you're mosaicing to a new raster how many bands there are, and that just means how many streams of data. In this case, it's just elevation. So the answer is 1. If it was a red, green, blue photograph, there would be 3 bands, RGB. And those other things can stay as default. So we just say, okay, mosaic to new raster, and wait for that to happen. 1, 2, 3, let's see how long this takes. 4, 5, 6, 7. Oh, I don't think it added it to the map. Let's see, it might have already finished. I'm gonna go hunt for it. So if we go back to students, look for me. Yeah, it's already there. Usually it defaults to adding it to the map, but it did not in this case. Oh, maybe it wasn't done. Confused it. No, here it comes. It's building pyramids. Okay, so there it is. I'll turn off these other ones. And if we can see, we turn it on and off. It's seamless now. So we don't need these other ones in here anymore. And if we want to create a color ramp, we can. Boom, there's our digital elevation model. Could even test it out by doing a profile across the Wasatch Mountains and seeing what that looks like. Valley, mountain front, steeper on the faulted side, more sloped on the back. Okay, so that worked well. On this other side in Arc Pro, we will basically what we go to do is an analysis. And so I'm going to close the symbology. I click on analysis, go to tools, and then I say find tool. and I want to mosaic to new raster. There it is. So this search function is very helpful in ArcPro. And so here we can collect both of those rasters. We choose the same output location. You'll only do this with one program, so you won't run into the problem I'm going to have, which is to have two files that are the same. Oh, again, it's asking just for a location, so that's there. And then same thing, so we'll call it CU for Central Utah DEM.TIFF. And the spatial reference is current map. And again, we have to choose 32-bit float. Cell size, we want 30 meters. One band, run. Let's see how fast it is on this one. 20%. I think it's done. It's not showing progress. Details. So one thing to note in terms of the speed is, oh, it's done. It's processing over the internet because I'm not on campus right now, and it's processing off that drive and then to my local computer. So this will be slower probably than what you do on campus. So now I don't need these ones anymore, so I'm going to remove them. So these are the same data sets. We can even show them in the same way if we want to, but maybe we'll just, since that's right there, we'll color it different. So yeah, that's basically, so this river drainage system right here is the Spanish Fork River. You can see it has a bunch of tributaries going in as that Spanish Fork River comes out into Utah Valley. Now we've got the data all together as one file, and so we are ready to start processing the stream network. And I'm going to show you how to do that using something called ArcHydroTools, which is built into the functionality of ArcGIS and ArcPro. So I'm going to stop sharing, and that's the end of tutorial 1, 13, almost 14 minutes.